Hello again, it's Bill Manuel, and today I'd like to do a video on the double slit experiment. And I have a little bit different interpretation, and it might make it easier for people to understand. So the double slit experiment is where they fire a photon from a single emission source, and then the photon evolves through a couple of slits, and then the photon appears at a screen. So let's break down this in a timeline so we can see what happens. Now, when a photon is emitted, there's an energy value assigned to it for its wavelength. However, when it's first emitted, nothing in the system knows what direction the photon's going. The photon has no idea, it has no reference to the system of where it's supposed to be. So as what you will see at that point is you'll see a wave function evolve like a sphere, steadily getting bigger and bigger. Now this is actually the first measurement because you can measure power consumption at the emitter to see that it's emitted a photon. So the photon carries all the energy. So it's not strictly pure probability. It has energy assigned, so it's actual real probability of what will happen. So if you measure that same photon one more time, and let's say the answer where you look on that globe, because the photon can appear anywhere on the surface of that sphere. And when you do find the photon on the surface of that sphere, now the system can draw a line from the point of emission to its second detection, and that allows it to assume particle-like properties. Now the system knows that it's going a specific direction and speed. In this case, photon goes light speed. So in any case, now it behaves as a particle. So we can go back to the double slit experiment, and if the photon is not found on the partition where the slits are, and it's not found anywhere else at that point in the evolution, it'll keep on going, and it'll interfere, the waves will interfere with the slits and cause that diffraction type of pattern. So then where the photon will appear will be based on the wave mechanics. So back to the double slit, we fired our photon, we saw consumption of power, so that was our first measurement. We know where it was in space. Now the second measurement, let's say we have a very sensitive photon detector, and it just detects absence, presence, that's all. Well, once the photon flies by there, now we know that it's a particle. It has enough definition that the wave function updates to particle-like state. Now, it's not a completely developed quantum object yet. Yes, it was a large sphere, and then it turned into a particle, but we're not done yet because we have polarization. It could be polarized left or right. So then we could actually do another measurement and collapse that bit of information, and now we have a fully developed photon. It's going to have basically we'll be able to find the position and also the phase relationship. And that's in a nutshell how the double slit experiment works. By the way, you watch my other videos, look in the comments section, look in the descriptions. Got a lot of good info. I've been making a lot of headway looking into gravity. I'm really starting to understand the universe now. And please leave any questions. I'll answer them if I can. And I might actually have to do a video like this. It's a little bit too long to put, just in a comment section. But have a great day, and we'll talk to you soon.